Welcome to day 2 of the IoT Boot Camp organized by Mitov Software and Embarcadero. My name is Bojan Mitov, the president of Mitov Software, and today I will demonstrate you how to connect to Arduino from Delphi. There are many ways to communicate with Arduino. Some of the most popular are simple serial communication, structured packet serial communication, communication over Ethernet or Wi-Fi, TCP or UDP, Bluetooth Classic, and Bluetooth LE. Now let's create some cool projects using some of those communications. For this project, we'll connect ultrasonic distance measurement sensor to our Arduino Nano. The sensor has 4 pins. We'll connect red wire to VCC power, black wire to ground, yellow wire to trigger, and green wire to echo. On the Nano side, we'll connect the black wire to one of the ground pins, the red wire to 5 volts, the yellow wire to digital pin 2, and the green wire to digital pin 3. We will start with new Visuino project. Select board type as Nano. From the tool palette, select Ultrasonic Ranger and drop it on the phone. Connect the output pin of pin trigger to digital pin 2. Connect the output pin of digital channel 3 to the input echo pin of the Ultrasonic Ranger. And connect the output of the Ultrasonic Ranger to the input of serial channel 0. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. The project is uploaded. Now we can connect with serial terminal and we will see the distance measured by the Ultrasonic Ranger. And if we point it to big distance, it will measure it in centimeters. And we can display this on the scope. Every now and then we'll have some noise from the sensor missing the bounce signal, but we should be able to map the room and the surrounding by pointing it in different directions. This is a big distance to one of the corners of the room. And this is the signal bouncing off of me, actually. And now bouncing off the camera. Now we can create a Delphi application to receive the distance from the sensor. We will start by adding COM port. Double-click on it. Select the COM port of our Arduino and a terminal component. Set the terminal to align client so it will take the full form. Switch to the open wire view. Connect the output of the COM port to the input of the terminal. compile and run the application. You can see the data arriving from the ultrasonic ranger and changing as we place object in front of it or point it in different directions. For this project, we'll connect analog XY joystick to Arduino Nano. The joystick has VRX and VRY analog signals, and it also has a switch that can be activated by pressing the joystick handle down. We'll connect black wire to the ground pin of the joystick, red wire to the 5 volts, green wire to the VRX, yellow wire to the VRY, and purple wire to the switch. The black wire will be connected to one of the Arduino Nano ground pins here. The red wire will be connected to 5 volts. The green wire will be connected to analog pin 0, yellow wire to analog pin 1. The purple wire will be connected to digital pin 2. In this project, we'll use structured packet communication to send multiple channels of data from Arduino. We'll start by adding a packet component. Click on this Tools button, add 2 binary analog channels and 1 binary digital channel. Expand the head marker and add 5555 in the bytes editor. This will be our unique header to easily discover the beginning of the packets. Connect the output pin of the packet 1 to the input pin of serial channel 0. Connect the input pin of the first analog channel of packet 1 to the output pin of analog channel 0 on the Arduino board. Connect the output pin of analog channel 1 to the input pin of the second analog channel of the packet 1, and connect the input of the digital element on packet 1 to the output of digital pin 2. Since we'll be using a joystick that does not have pull-up resistor on the digital pin, we will use the built-in pull-up resistor on the Arduino Nano by enabling the isPullUp property of digital channel 2. Generate the code, compile and upload the code. The code is uploaded. Now we can select packet 1 as format for our communication. The terminal will be disabled. The scope immediately will be populated with the 3 channels for the communication. An instrument wrap will appear with 2 gauges and LED to display the data from the channels. If we connect, we will see the data arriving from the joystick We can change it by moving the joystick, and we can switch on and off the switch. We can monitor the same on the gauges. And on the scope. When I created this project, I did not change the board from Uno to Nano. Since Uno and Nano have exactly the same capabilities and pins, and just differ by its size, this works perfectly fine. It is good practice, however, to change the board to the corresponding board, even when it is not necessary, to make sure there is no confusion. Now it's time to connect to Arduino from Delphi. We'll start with new VCL application. We'll add COM port component. Double-click on it and select the COM port of our Arduino. We'll add unpacked component. Scope component. Two angular gauges. And an LED. We'll set the max for the gauges to 1, since the values from the Arduino will be between 0 and 1. Switch to the open wire view. Double-click on the unpacked component. Add 2 floating point channels and 1 Boolean channel. Close the elements editor. Expand the head marker. Click on the period button for the bytes and enter 5555, the same as we did in Arduino. Close the bytes editor. Connect the output pin of the COM port to the input pin of the unpacked component. Add 2 more channels to the scope component. Connect the output pin of the first floating point channel to channel 0 of the scope and the first angular gauge. The output of the second floating point channel to channel 1 of the scope and the second gauge. The output of the Boolean channel to channel 2 of the scope and the input of the LED. Compile and run the application. We can use the joystick to change the data that arrives on the scope and the gauges, and by pressing it, we can turn on and off the LED. This also will be shown on the scope. For this project, I will connect a DHT11 temperature and humidity sensor to the Node MCU Mini from my IoT kit. We'll connect a red wire to the VCC pin of the DHT11, black wire to the ground pin, and blue wire to the data pin. The DHT11 uses a proprietary digital protocol to communicate with the microcontroller. On the Node MCU, we'll connect the black wire to ground, the red wire to one of the 3.3 volt pins, and the blue wire to digital pin 3. You can see also the pins labeled on the top of the module. We will start with new Visuino project. Select the board as Node MCU. The Node MCU has Wi-Fi module. First, we need to specify the access point where we want the module to connect. Select Access Points and click on the period button. Add access point. Enter the name of the access point and the password. Close the access points dialog. Next, we need to specify the name of the module so we can discover it on the network. We will call it DHT11 server. The module is ready to connect to the network. Now we need to add server socket. Select Sockets and click on the period button. Then add a TCP/IP server socket. Set the port of the socket to 8080 and close the sockets dialog. To read data from the DHT11 module, we need to add Visuino component for it. The module is connected on digital pin 3, so we'll connect the sensor output pin of the component to the digital input pin of digital channel 3. To send both temperature and humidity to the socket, we can use a structure. Select Make Structure Component and drop it in the design area. Click on the Tools button and add 2 analog channels. Close the Elements Editor, connect the temperature to the first element and the humidity to the input pin of the second one. Connect the output of the make structure to the input of the socket. The project is ready, however, if we run it, it will send data very fast over the socket. We would like to send temperature and humidity data only once a second. For this, we can use a clock generator. We will connect the output of the clock generator to the clock input pin of make structure. This will specify that the structure is sent only once a second. Now we can generate the code and open the Arduino IDE. Select the board. In this case, Node MCU version 1.0. Select the port. In my case, COM port 8. Compile and upload the sketch. The code is uploading. The project is ready to test. Now we can connect to the Node MCU from Delphi. First, we'll add a socket component. We'll set the host to DHT11 server and dot at the end. Adding dot at the end is important because of the way the name is resolved on the network. For port, we'll enter 8080. We will add split structure component. Scope component. Thermometer. And analog gauge. We will switch to the OpenWire view. We will click on the Tools button of the split structure and add two float channels. Close the Elements editor. Connect the output of the client socket to the input pin of the structure. Add one more channel to the scope component. Connect the two channels to the two elements of the split structure, and the output of the first element to the thermometer, the output of the second element to the angular gauge. Now we can compile and run the application. You can see that the data starts arriving once a second. And if I warm up the sensor, the temperature will start changing and the humidity will increase from my finger. The DHT11 is not very sensitive sensor, but it is cheap and very affordable. So it is very often used for small test projects. You can see the data updating once a second. And if I move away my finger, the temperature will stop dropping and the humidity will return to normal. For this project, I will connect I2C organic LED display to the NOT MCU Mini from the kit. The display has 4 pins. We'll connect black wire to the ground pin, red wire to the VCC power, yellow wire to the SCL clock for the I2C, green wire to the SDA data for the I2C. On the NOT MCU side, we'll connect the black wire to one of the ground pins, red wire to one of the 3.3 volt pins, the yellow wire SCL to digital pin 1, clock for the I2C, and the green wire to digital pin 2, data for the I2C. We will start with new Visuino project. Select the board as not MCU. Expand modules, Wi-Fi, add access point, set the access point SSID and password, close the access points editor. In the modules Wi-Fi, set host name as OLED, add a server socket, set the socket port to 8080, close the sockets editor. Now it's time to add components to control the organic LED display. Type OLED and select the I2C version. Drop it in the design area. Connect the output pin of the display to the input pin of the I2C channel. Connect the output pin of the server socket to the input pin of the display. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. The code is uploaded and the Node MCU is ready. Now it's time to connect to the module from Delphi. We will start by adding a client socket component. Set the host as OLED dot. Remember to put the dot at the end, otherwise the module will not be discovered on the network. Set the port to 8080. Add a memo. Set the alignment to client to take the full form. Clear the lines so the memo will be clean at the beginning. Switch to events and create on key press event. In the event for the client socket, call send and pass the key. Compile and run the application. If we type anything in the memo, it will appear on our display. As you can see, the display is working as programmed. For this project, we'll connect a servo to the Node MCU Mini from the kit. The servo has 3 wires, orange, red and brown. The brown wire is ground and we'll extend it with male to female jumper wire of black color for the ground. The red wire is power and we'll extend it with red male to female jumper wire. The orange wire controls the servo and we extend it with orange wire. The servo is 5 volts and the Node MCU Mini has VIN pin that conveniently has 5 volts from the USB. We'll connect the red wire to this pin. We'll connect the black wire to the ground pin and we'll connect the orange wire to digital pin 3. We will start with new Arduino project. Select board type as Node MCU. Expand modules, Wi-Fi. Set the host name as servo. Add access point. Set SSID for the access point, in my case ACES, and password. Close the access points editor. Expand modules, Wi-Fi, and add a server socket. Set the port to 8080. Close the sockets editor. The data will arrive as integer value. We can use split structure to extract the value from the packet. Connect the output pin of the server socket to the input pin of split structure. Click on the Tools button and add integer channel. Close the elements editor. The integer value will be between 0 and 1000. We need to convert it to range of 0 to 1 for the servo. For this, we can divide it by 1000. Add divide by value component. Set the value to 1000. Connect the output of the integer element to the input of divide by value. Now we need to add component to control the servo. Connect the output pin of divide by value to the input pin of the servo control component. And connect the output of the servo component to the digital input pin of digital channel 3 where our servo is connected. Generate the Arduino code and open the Arduino IDE. Compile and upload the project. The code is uploaded and the module is ready. Now it's time to connect to the module from Delphi. We will start by adding client socket component. Set the host name as servo followed by dot. Make sure you add the dot at the end, otherwise the module will not be discovered on the network. Set the port number to 8080. To pack the data, we will use make structure. And we'll use a track bar to control the servo. Set the max property of the track bar to 1000. Select the position property and click on the button at front of the property name. Select integer source pin. This will add integer source pin to the position property using Visual Live Binding. Click on the Open Wire tab. Click on the Tools button of the Make structure and add integer channel. Connect the position pin of the track bar to the in pin of the integer element. Connect the out pin of the make structure to the in pin of the socket. Compile and run the application. You can see that we can use the track bar to control the servo.
Great, thank you, Boyan. This is Jim McKeith. I'm going to take it from here and show you a few other possibilities, starting with some Arduino, and then I'll move into some of the other IoT components that are part of RAD Studio. So in this example, what I'm going to do is it's kind of going to be the round trip. We're going to read a value through inputs on the Arduino and then make a decision based on input at the computer's level, and at that point, then push the value back out to the Arduino again. Now, the example is going to be simple enough that it could be done on the Arduino itself. But the reason I'm doing this at the computer level is so that the computer could access databases or maybe input from another person that's running on the computer side or something along those lines. So it's some sort of more complex scenario than the simple demo shows. But you'll see the potential of what you're able to do through a round trip in this sample here. Now I've connected the keyboard matrix to my Arduino Nano here. And the pin that it's connected to, let's see if we can get this to come in focus. So you'll notice that, come on, let's focus. There we go. All right. So right there, that is digital 3, and that is digital 2. And if you look on the keyboard matrix, there's a little number 1 right there, and a little number 8 right there. There's the 8, and there's the 1. Oh, there we go, now I can see it. So there's the 8, there's the 1. Alright, and so this is the side that's got the other printing on it here. And so the 8 is going to be connected to digital 9, and the 1 is connected to digital 2. Instead of building this sketch from scratch, I'm going to explain how it works and why I didn't build it from scratch. This is an Arduino Nano because that's the board I'm connecting to. And I'm using the keypad here. Now, with the keypad, you come in here and you put a keyboard group in, or a character key group in here. And then in the character key group, you add keys. Now, there's 16 keys to add, and for each key, you have to put the value, what character it is. So here, see, character key 1 is a D, 2 is a pound sign, etc. I didn't want to go through and program all these in, and I went out and looked at Boyan's Instructables, and sure enough, he had a project that did this already. So I just downloaded that one and made a couple modifications. I will point out here, though, this is pin 0 is digital 2, which is what we wired it to on our Nano. And also this one uses the rows and columns. The rows come around here and connect on this other side, which I thought was kind of interesting. Now, one modification I made to this, I'll point out here that the output from the keypad is sent back through the serial port here. But then the serial port is read, and whatever comes from that, I use this compare character value here, and I'm comparing it to a space. I could compare it to any character, any single character, but I decided to use space. And so what happens is if the character that's read from the serial port is a space, then we send a signal around here to pin 13, which is the LED pin, so it'll turn the LED on. And so what'll happen is if I receive a space back through the serial port, the LED comes on. If I receive any other character, the LED goes off. So you can download this from Boyan and make that one modification there, or you can, I'll include this on the download page, so you can just download it from there as well, from the main page for the today as well. So I'll go ahead and deploy this. And while we're doing that, I'll jump over here to Delphi. Now in Delphi, I've put down a communication lab COM port, although you can use other COM ports from other libraries that include COM ports. But in this case, I use communication lab COM port and a terminal. And I use OpenWire to connect these up so that I read the output from the COM port and put it into the terminal here to display it. Now, at this point, all this would do is display the value that I'm getting back from that COM port to the user, so the user could see what keypads or numbers being pressed on the keypad. But what I've done is I've added some code here to take this a step further. So I'm reading the see what the text ends with. So it's just going to keep getting this longer and longer string of text. And if the last 3 digits are 333, then I'm going to send that space. Otherwise, I'm going to send an A, which could be any other character, but in this case, I'm sending an A. So let's go ahead and run this. Here is the number pad there, and I'm going to come in here and I'm going to type, let's go ahead and type 333, 3. So you see there the 3 shows up, 3, 3, And you see this second LED lit up here. And then as soon as I type another character, so I'll type A, which my A doesn't work on my number pad. Oh, I use D, that one works. Or pound, there we go, pound works. So I hit pound and the light goes off. And then I hit 3, 3, 3, and it lights back up again, pound, it goes off. If I type another character sequence, so 5, 6, 7, nothing, but then as soon as I hit 3, 3, 3, there we go, it lights up again. So the idea behind this, and I was going to use the RGB one and show different colors for different users was the idea, but I don't have enough pins to do that correctly, so I would need like a different type of board, maybe a Mega or a regular Arduino. But what this does is the idea is that you could have a code that your user types in here on the keypad that would then trigger, so that when they type this code in here, it goes to the software, to the Delphi software, and then the Delphi software can then recognize that user, in this case the user number is 333, and send a signal back to here, which could unlock a lock, invoke some sort of action based on that. So what I was going to go with like a nurse's station, for example. So you go up here and the nurse says, okay, I have patient 333, punches it in, the light lights up saying, okay, I'm ready to take vitals for this patient now, and it can collect all the vitals for that patient, knowing who the patient is based on the value punched in here. It would also check to see if you typed an invalid value, then you could get feedback from that as well using maybe the OLED or the RGB LED, one of those options, something that's a little more information coming from it than just a single LED here. But you get the idea as far as how to do this. So let's take a look at some of the IoT components that are built into RAD Studio. They're available through the Get It Package Manager. So I'm going to come here, Get It Package Manager, and select the category of Internet of Things components. Now there's 54 components right now. Each of these different components you can connect to control. And apparently I hit a key on the keyboard that opened a browser window. Oh, right here, I hit that, opens a browser window. See? Click here to go to the product homepage. So there you go, you can go to the homepage to buy these different things. Beacon Fence is our solution that lets you work with multiple beacons, whereas the rest of these are specific devices that you can buy these devices and then talk to these individual devices. Now I'm going to point something out here. Let's go to the heart rate. Heart rate. So there's multiple heart rate monitors here. We see there's 8 different entries here for heart rate monitors. Some of these are specific. So this is the Polar H7, the Zephyr, for example, actually have both of these heart rate monitors. Each of these are different brands of heart rate monitors, whereas this one here is a generic heart rate monitor. So what that means, though, is the generic heart rate monitor is just the generic official spec, the official service definition for a heart rate monitor. All of these, or at least I know these two do, but I believe all of these implement this one here, but then they add other things, other layers on top of that interface so that you can get additional information. So I'm going to go ahead and install the generic heart rate monitor here. And I have to agree to the license agreement here. It downloads it and installs it, builds it all, installs it into the IDE, so we're ready to go. And then what it does is it opens up a sample project for you here. So I'm going to go ahead and close this and take a look at the sample project. Now on the sample project, you're going to see it has, this is the generic heart rate monitor component. So this component was installed into the IDE so that we can work with it. And then this application knows how to talk to that component. Now this is kind of a generic looking application, not just because it's the generic heart rate monitor, but it's a basic application that can then read and write multiple values. In the code, if you look in here, if we scroll down here, we're going to find there's a spot right here where these specifies the service GUIDs that are used to identify that particular service, those particular services. The rest of this code is going to be pretty much identical, I think identical across all these sample applications. But those GUIDs there are where it specifies the specific GUIDs, the gap profiles that are used to identify those different services that are supported by that component. So I'm going to go ahead and run this here. I am going to run it on OS 10, and the reason is that I'm running in a virtual machine, and trying to get the Bluetooth connection inside the virtual machine is a pain unless I use a separate Bluetooth dongle, which is very small and I appear to have misplaced. So that's fine. That's the great thing about Delphi is it runs on all these different platforms. So let's go ahead and run this on OS 10. I got to switch over here to my desktop. So here it is running on OS 10, and I can click to discover Bluetooth LE devices. So this is going to discover all heart rate monitor service devices. No devices found. Oh, come on. I have 2 devices on right now. Maybe they switched off because I had them for too long. Okay, let's try this again. So there's the polar. Why aren't you seeing the Zephyr? Oh, there we go. The light's on. So yeah, they shut off. Apparently my heart stopped and they just said, oh, we're not doing anything anymore. And so they quit reporting information. There we go. We're seeing both devices. That's the fun thing about working with all these different devices is keeping them all turned on, batteries alive, so on and so forth. So here's the Polar H7 and here's the Zephyr HXM. And then I'm not sure if this is a serial number, a model number, whatever, for that particular device. So this is the name of the device. Now I can select one of these, and once I do, it's connecting to the device. I found sometimes if it doesn't connect, and you time it out and click it. Now it works quick. So yeah, sometimes it's not able to connect on the first attempt. And once I do that, then I can come down here to the services. So the way it works is you have read and write, or read and subscribe services. And I can come down here to a service. I can say what service, the heart rate service. And that heart rate service has 2 different properties. One's the body sensor location and the heart rate count. So I'm going to go to the body sensor location and hit read. And this is going to ask the heart rate monitor where it reports as being attached on my body. It says it's on my chest. Now, this is hard-coded for these heart rate monitors, but some heart rate monitors, for example, could have different positions they support. But these heart rate monitors always report chest. And then if I want to get the value, I come down here and I want to say I'm going to subscribe to the service for the heart rate and get the heart rate measurement and hit subscribe. And it's going to start reporting my heart rate here in just a second. There we go. My heart rate is 74 beats per minute. And in theory, if I move around or let's see if I can, yeah, there we go. See, it's going up, 76. And if I set really still, there we go, still going up because I was bouncing on my exercise ball. Wow, look at that. So there's a little bit of delay there. I'm not sure why there's delay. Earlier, this was much faster, so I'm not sure if it's because I'm recording or what, but everything has gone slower. So I'm going to take some slow, deep breaths and see if I can reduce my heart rate now. So there you go. Got my heart rate start going back down again. So there's reading my heart rate. So I'm going to switch over here to the Zephyr. Connecting to the device, connected. And again, let's just come in here and read the heart rate on the Zephyr. Heart rate measurement, subscribe. 73. So I'll try just taking a deep breath and it's calming down. You know what? It appears the Zephyr is just faster responding than the Polar was, interestingly. So let's go heart rate up here. I'm not sure what this other value here is. I can write to it, but not read from it. So anyway, it goes through. What it does is it's enumerating the Bluetooth device, saying what services do you offer, what properties, and or based on the component, and whether you can read or write to it. So I'm not sure what you're writing to this one here. But anyway, that's fine. Got the main thing here that I wanted to show you was just that you can read and write to it. So now what's the difference? Why would you want to go with the Zephyr component or the Polar component specifically? I'm glad you asked. So let's take a look at that. So let's come back in here to Tools, get it, Package Manager, We'll say heart. And I'm going to go ahead and install the Zephyr. Let's go ahead and install it and build it. Save changes the demo. No. So it closed the generic one, opened the Zephyr demo. And actually, I don't need to install the Polar. I was going to install the Polar too, but we'll just go with the Zephyr for now. So now we're using the Zephyr heart rate monitor component. We still have the, if I go search heart, we have the generic and the Zephyr both installed here. So I could use either one, but right now this is set up to use the Zephyr. Now if I look in the code here, when I scroll down here to the spot, see this? We have a whole lot of additional services that are programmed in here that it knows to look for. So let's go ahead and run this one on my Mac again. And I have tested these. These do work on Windows. You just need to have that Bluetooth dongle. I think my son borrowed it because he could connect his Bluetooth device to the old desktop upstairs. So discovering devices. No devices found. Yes, there are devices here. My heart did not stop. There we go. They're both there. I don't know. Apparently it didn't have the handshake with the OS yet. So we're using the Zephyr component, but it found both devices. Now the reason is because at the discovery level, it is discovering devices that implement the heart rate profile, the gap profile. So both of these implement that profile. So it discovers both of them. There's a lot of other Bluetooth LE devices around here that aren't being discovered because they don't implement the Bluetooth profile. Now at this point, I could look at these to determine in code which one is a Zephyr and which one isn't, but it's not filtering that. So now if I come here to the Zephyr and connect to it, it's connected on the first try, yes. And go to service, notice we have additional information here. We have device information, which I can come over here. I can get system ID, serial number, manufacturer name, IEEE. So let's go system ID, read that. There's a system ID. So there's lots of other system information here. So this is stuff that was added by Zephyr to their heart rate monitor. Additional things that were added to it that are not part of the baseline heart rate monitor gap profile. We can also get battery service information. So see if my battery's dead or not yet. That's really useful to have. 68. So I guess it's 68% there. Now down here, I can still subscribe to the battery service. That's kind of useful. So I can find out what the battery is as it's changing it. So the difference between a read and a subscribe is a read reads the value once, whereas subscribe means that when it changes, it'll give me a value. So apparently, I'm not going to find out what it is until it changes battery values there. But let's go ahead and subscribe. I'm not sure what this one is here. Oh, the Zephyr measurement. So let's see what that is. So this one is pulling out a whole bunch of information here. Activity field, peak acceleration. So this is getting a lot more information about. It's probably like reporting like whether the heart rate is going up or down, and some different information that would be more useful. So the Zephyr app that you have on your phone would be able to tap into that additional information. Of course, since you're using this, since you're using Delphi or C++ Builder and have access to this Zephyr specific component, you of course can tap into all that information as well. So subscribe to the heart rate, and we should see the heart rate there is right now at 80 beats per minute. So I'm getting excited because of all these cool features. Of course, now I'm not excited and the heart rate's coming back down again. So what happens if we connect to the Polar now? So connect to the Polar, come here. All these property drop-downs are still the same because those are, we've told that we can look for these. Now, if I go to, actually let's come on here, we'll do service, heart rate measurement, and hit subscribe. Yeah, the Polar is just slower than the Zephyr. That's interesting. There we go. We're getting the values back. So this is the baseline heart rate service that is supported on both devices. But if I go in here and say, let's read the battery service, the battery level, and hit read, it doesn't get anything back. Oh, it did. So their battery service is compatible. Here, I was going to say it doesn't work. But if I come down here and do the, there was that one that was the Zephyr. That's right, this one here. The Zephyr. Yep. Oh, I have to select characteristic first. Property. Zephyr measurement. Hit subscribe. Wow. So that now you know if you're buying a heart rate monitor, get the Zephyr, not the Polar. The Zephyr is a lot faster response. Yeah, so we're not getting anything back. So it doesn't know how to respond to that one. Likewise, I think if we come up here and get device information, we'll try it and see. I might be surprised. And hit read for the system ID. Dun, 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 dun. And nothing came back. So it doesn't know how to respond to that one. So some of these are compatible, some of them are not. And so, but if I were to go through and install the Polar component, tools, get it package manager. So we'll install the Polar heart rate monitor. Look at, we got cadence sensors, speed sensors, stride sensors. Wow, you could get like a whole Polar set of sensors installed on you and go out and write an app that can connect all of them and do all of them. It's really amazing amount of possibilities here. Also, something else, if you are interested, you could implement your own Bluetooth device. We have another Bluetooth Explorer Bluetooth LE Explorer you can use to discover information about devices as well. Let's not save changes to the Zephyr. So we're running the Polar one now. And if I'm not going to bother going into the code, but if we did go into the code, it would be a different set of GUIDs there. So we'll drag this one over here so we can see it. Click Discover Devices. And it just saw the Polar. That's interesting. So I wonder if this one is looking at a different service instead of the... Yep, we just used the Polar. So this one is more selective in its filtering. So if I come in here to the Polar, and we're connecting to the Polar now. That's right, the Polar is slower to connect to. That's too slow. I'm impatient. Connected. Okay, and we come down here to service. So again, we have device information here. But it's probably might be using a different GUID behind the scenes. Let's see if it pulls it. Maybe it doesn't pull a value back. Maybe the Polar just doesn't report device information, even though it's supposed to support it. There we go. So we got device information back this time, whereas we didn't before. If I come down here, it only has heart rate, so you can't subscribe to the battery or that additional special Zephyr packet that came back. So this one only has the heart rate there. So this doesn't add a whole lot over the base heart rate monitor. It adds the device information, the battery service over the base heart rate monitor, but doesn't add the additional, like Zephyr did, the things that are specific to the Zephyr. Like you can subscribe to the battery and get the more detailed packet back. Okay, that's kind of the introduction to Bluetooth LE or how to use Bluetooth LE components. There's a whole bunch of those components in there, and actually a lot of other devices that are non-Bluetooth devices as well in here. So these are, you're connecting over the probably Wi-Fi to the Z-Wave devices so that you can control Z-Wave devices. You're going to connect to the base station over Wi-Fi so you can then connect to the Z-Wave devices. A lot of these are over Wi-Fi connections, yeah, or Bluetooth. If you're connecting directly to the device, it's Bluetooth LE. If you're connecting to like a base station or something like that, like probably the Honeywell Z-Wave. So if it's Z-Wave, you don't have a Z-Wave antenna directly in your device. So what you're using is you're going to use Wi-Fi to connect to the base station, and the base station is going to connect to the device via Z-Wave. Interestingly, here's this one here. It's got its own SDK you use. This is you wear this armband, and it can sense the muscles in your arm, and so as you move your hand, it returns gesture information. So you can make like gestures with your fingers or movements with your hand and get that information back to you. pretty cool. I have one of those and play with it. I do have a scale, but I couldn't find it. Your blood pressure monitors, more speed monitors, more locks. I need to get some of these fancy locks for my house. They're just so cool. Oh, there's a gas sensor. These are the Texas Instruments sensor tags. You can get these. These are what they are. Is they're a collection of sensors that you can read from, and so you can pick up these sensor tags and do quite a bit of read quite a bit of information from them. They're developer, developer tags that you can work with to do things. And then there's the other scale, more heart rate monitors, and another door lock. So there you go. That's the different devices that are available through the Get It Internet of Things ThingPoint options. If you would like some more information, visit our IoT Boot Camp homepage, which is embt.co/IoT Boot Camp 2017. That's where we're going to have links to all the replays, and all the additional resources will also be available there. It's a process to gather resources and put them up on there, but they should all be up available on there eventually. So do visit that page, embt.co/IoT Boot Camp 2017. Day 1 replay is already available there. Day 2 and all the additional days will be available there in the near future.
Boyan, you're still out there with us, right?
That is correct.
Great. Well, this was another fun day. I think it was neat to see and to start thinking about how to connect these applications, or these devices we're building on the Arduino, and connecting them back to Delphi. Now, actually, I had a question that came up, and you may have clarified this, but I know that on the Arduino side, the programs you write, they call them sketches, which I always thought was kind of an odd thing to call them. Is that what you call them as well in Arduino, or?
I tend to call them just projects or designs in Arduino, and yeah, I don't know. Well, the reason they probably call them sketches is exactly what I mentioned on the first day. The Arduino IDE is literally just a notepad, so it's not like IDE in the sense we are used to thinking about IDE. It's just a little bit, just a little bit fancier notepad, nothing more than that. So if you're using notepad, you probably are doing sketches there, right? I mean, kind of, I guess that's the logic. But in Arduino you do graphical, you don't really literally program, you design your code. So I tend to call them projects or designs, but they are surely not sketches.
I felt like that because it's more visual, it felt to me like it was more of a sketch than I saw with Arduino. Because Arduino was like, this is, yeah, like you said, it's just kind of a notepad, but you're writing code. And so in my mind, when you're writing code, it's not a sketch. But Arduino, you're drawing things. I really like it because it's like, oh, this is, I see the pins for my device, so this is my device I'm working with, right? It feels like I'm dealing with the physical device there. But okay, there's a question here about a CURL type component for Arduino, so where you could make connections, HTTP connections, and open URLs and stuff like that. Is there anything like that available in Arduino, or something like that might be coming?
Yeah, you can. I mean, there's socket capabilities, and we already use some of them. And yes, you can use. You can run servers. I have already quite few instructables and tutorials on this, where you can create a web server inside Node MCU and connect to that web server and access information from there, or connect to a web server through even GSM, GPRS type of connection over cellular phone connection. So yes, this capability is there, and there are even components to construct and parse JSON packets, JSON text. I am working to make that even simpler in the future, but again, that's work in progress, and yeah, I mean, many more things are gonna come in the following months.
So Kaz asking here, does the Visuino IDE come with the Arduino starter kit?
The starter kit is the IoT kit is just a kit that can be used as with the normal Arduino or with Visuino. The price of Visuino is not included in the kit. And again, I am not really connected with the MakerFabs people. I simply really like the quality that I have seen from their products, and that is why I suggested that we work with them, because I knew that they're going to do a good job when they put the kit for us together. But no, this is the price of the kit without Visuino. And again, you don't really, if you just want to play a little bit and don't plan to use it for anything serious, you don't need to purchase Visuino. You can just use it for free within the 5 minutes free usage, or get a trial key and play with it.
Let's see. Someone's asking if there is a delay on the kit due to Chinese New Year. Maybe. I got my kit pretty quick, so it depends on your shipping you got. But there could be a delay because Chinese New Year, it is a holiday.
I think they were, not only they did provide good quality, and they did a good job picking the elements for the kit working. I work with them, but they were involved, but they seem to have done quite good job in quickly shipping the kits and stuff like that. So I am pleased personally with what I have seen from them.
Yeah, I really excited about my kit. It was, although my keyboard matrix, it probably because it's kind of flimsy, I felt like some of the keys didn't work really well. The number keys worked great, so I'm not sure if there's something I am doing wrong. But anyway, yeah, I was really pleased with all the stuff I played with in it and saw you putting things together on. Oh, Ian saying there is a delay. There is a delay because of the Chinese New Year.
I see. Yeah, I'm sorry about that, but just bad timing, I'm afraid.
Do you want to talk about the licensing? So you mentioned that you can use Visuino for free. What I'm going to go on record say I went out and bought Visuino as soon as I saw it at Code Rage, because I just thought it was so awesome. But anyway, if you want to go ahead and talk in more detail about the licensing of Visuino, as well as Communication Lab and some of the other parts that we looked at here today, and I'll bring up the pages for them as well.
Sure, absolutely. So Visuino, you can run it, and it will run without registration or anything for 5 minutes, and then you can run it again and run it for another 5 minutes, and so on. And 5 minutes is very often enough to do plenty of work in it. As you have seen, it's a very high productivity development tool. Then you can go to the Visuino website, create an account, and request a trial key, which will give you 1 month of full functionality and no time restriction on running the Visuino. And if you really like it, you can buy a license, which is $9.99. And this license comes with 3 months of updates to newer versions. So whatever version is released in the 3 months following your buy, you will get those versions. If you want to continue to receive updates, you can pay $9.99 and you will get 12 additional months of updates. Or for $19.98, you can get upfront 16 months plus 1 bonus month of constant updates to the latest versions. And again, when that subscription expires, the versions you have downloaded, they will continue to work. It's not a restriction, the license is forever. But you will simply not be covered for newer versions, and you will not be able to get newer versions. The Communication Lab is free for personal purposes. Let me take a look, because I have so many products, I don't remember all of the prices off the top of my head.
Here, I'll bring it up here.
But, yeah, Communication Lab without source code is $39. We also demonstrated, used in the code we use Plot Lab, which is also, if you just want to play with it, it's fully functional and free. If you want to use it commercially, it's $289. And we also used Instrument Lab, which the instrument lab is $199, and again, if you want to use it for personal purposes or just to experiment with it, you can use it for free. Both plot lab and instrument lab will, if you use the free version, will have a small message saying free version on the components, otherwise will be fully functional. So I mean, you don't, the minimum you need to talk to Visuino and Arduino is communication lab. The instrument lab and plot lab makes it easier to visualize the data with gauges and plotting it and so on and so forth. And of course, it all integrates with all of the other components and component packages that Mitu software offers. So you can go all the way to quite complex integrated solutions.
Now, do you have a disclaimer or release for people to sign when they get the intelligence lab that they promise not to build Skynet and build robots that are going to take over the world? I'm just thinking really dangerous set of components here if it's in the wrong hands.
Well, I have a special NDA agreement with some underworld powers which have requested me not to sign such agreement. No, I'm just joking. Yeah, I think although intelligence lab is quite powerful, I don't think it yet is at the level of endangering of taking over the world.
Okay, well that's good. That's good. Because I'm just thinking, you know, you build this your Arduino robot with Visuino, you connect to its communication lab, you use Vision Lab to make it understand what it's seeing, and Intelligence Lab to, I don't know, it sounds dangerous to me.
Yeah, I'll have to have a word with my robot, I guess. Yeah, I've seen him start behaving kind of strangely. Yeah. Gives me a pulse. Just joking.
Okay, some questions here about whether or not we could use VCL or FireMonkey. The communication lab, does that work on?
Yes. Communication lab works in FireMonkey, and I have at the moment it is Windows, but I have already posted. It's already partially ported to other platforms, and the hope is in the next few months that literally all of the components, I mean not all of the components, but all of the libraries will be at least partially available on other platforms. And slowly more and more components will appear there. There always will be platform-specific components because, let's say, when you do video processing, video capturing, as example, is done slightly different in different platforms. So most likely that will be reflected in the specific components that do, as example, video capturing. But as example, large portion of the video processing components already work both under Mac and Android, and a portion of the communication lab components already work, at least under Mac. I have not had chance to play under Android yet with them. So yes, you can use them in FireMonkey under Windows, and they will slowly start to become available for other platforms as well.
Okay. Jeffrey's saying he just talked to MakerFabs yesterday, and it sounds like there's a delay on the Node MC units, 2-week delay. So they've apparently had a lot of demand from our Maker Kit with the IoT Boot Camp, which is, I guess, exciting at one degree, but also frustrating, I'm sure, for those of you that have not received your kits yet. So sorry about that. They will be available if you, that's a great kit, but if you want to get hardware, another way you can get your hands on hardware is eBay has a lot of hardware. You can get a lot of hardware on what was it? Adafruit.
Yes, Adafruit. Yes, or SparkFun.
SparkFun are two big providers. Internet of Things for everyone. There we go. But you can come out here and find lots of Arduino devices here. Just you're going to want to look at what the device you're getting is. They have some of their own devices as well on here. See, here's their starter kit, right? Look, $65. It's more expensive. So I was really pleased with the Maker. And I was like, if we can get a kit under $50, that's awesome. And it has 2 controllers.
Yeah, I have to say that majority of the components in that kit are pretty much picked by me. I work with Maker Fabs, and I picked, first of all, I picked two controllers, one to be the Arduino for simple projects and tasks, and the other one to be Node MCU ESP8266 based. So you will have Wi-Fi and IoT capabilities right out of the box. That's kind of unique about this kit. Not many kits come with such set of two different type of controllers. Also included, we didn't have chance to work with that, but included is a Bluetooth module, again intended for us to do some more IoT stuff. And then the rest of the sensors that I have picked, they're picked to be very easily to connect just with wires without the need of breadboarding or anything like that, or really more complex understanding of electronics. The idea was that most of the people that probably will be starting with this, they don't have extensive electronics background. So I wanted to have modules that are relatively easy to understand, relatively easy to figure out, and relatively easy to follow tutorials on how to hook them with minimum mistakes. So this kit is specifically selected to be done this way, and it's different than most kits that you will find otherwise.
Yeah, I was really pleased with the kit when you sent over the list you put together, because this is like exactly what I was hoping for. Because I like the fact there's inputs and outputs, because all the other kits are like, hey, look, this kit comes with 25 LEDs. I'm like, okay, that's great, but I want to actually read something in. Question here about the Node MCU. How does the networking on the Node MCU work? Some people are asking, does it use MDNS, or what's going on behind the scenes there?
Yeah, they have firmware. Their firmware appears to be proprietary. The Node MCU, okay, the Node MCU uses ESP8266, which has an interesting history. It is used in many, you already showed a number of devices that are listed in the Get It. I wouldn't be surprised if a number of those devices actually have Node MCU inside, not Node MCU, but ESP8266 inside. I know that some smart light bulbs and some sockets that they were selling in Home Depot and stuff like that, they have the module inside. Initially, the ESP8266 was marketed to the Arduino community as a simply slave Wi-Fi module that you can hook to your Arduino and use it to, in essence, add Wi-Fi functionality to existing Arduino boards. Then people discovered that the module has a very powerful CPU on its own, and it has I/O capabilities, and then it morphed into its own controller. But again, it has this firmware which is done by Espressif, the company that makes the chip. I'm not 100% sure I know all of the capabilities that they have put in the firmware. I know that it has some DNS capabilities because, I mean, it registers on my DNS server and I can discover it. It supports DHCP, obviously, because it can obtain dynamic IP, or of course you can specify fixed IP, but I'm not sure about all of the protocols that they have implemented in the firmware. It is kind of intended to be, you just power it, you just tell it to register on the network, and it does it behind the scenes. What exactly they have internally implemented and which particular protocols they have internally implemented, I simply don't know.
Okay. Is there any tips you have as far as troubleshooting connectivity for that? Can you maybe have it write the IP address out, or just let you know if it's going to work on
the first the module I know that you are working on that. The module has can be the module is capable of being hotspot itself, or it can connect to other hotspots, which makes it among other things very interesting module, because I can connect them to each other without the usage of any Wi-Fi hotspot. So as example, I have a remote thermostat that I have kind of put together myself, which I have made one of the modules to be a hotspot, and the other module directly connects to it. and then I can control the temperature from one of the rooms through the entire house and monitor the temperature in that particular room. I did couple of tutorials using this functionality, including remotely controlling a robot over Wi-Fi, where one of the modules connected to the other module as a hotspot. So one of the ways to do that is you can make, first of all, the module to be a hotspot and see if this hotspot appears on your, let's say, mobile phone or device. Yeah, it's not this particular project, but there was a Wi-Fi robot. You can probably search. It's a little bit lower. Yeah, if you view all of the instructables, yes, and if you scroll down, you will see it. It's more toward the end. I used the Wii controller to control it. Right here. Stop it. Yeah, you passed it.
I passed it.
Yeah. A little above this one. A little above this one.
There it is. All right.
Yeah, this one. Yes. So here I'm using a Wii remote controller connected to one node MCU, and that node MCU is talking to another node MCU which is on the robot, and I'm controlling it and goofing with it. Right? So generally speaking, you have some fun.
I gotta say that is really cool. I still get a kick out every time I build software and deploy it to a mobile device. It just seems really cool. But building it and deploying it to, some making lights light up and, stuff like that is really exciting to see all that working like that. So, yeah, cool stuff.
Yeah, it's a lot of fun. But what I was saying is that if you program the node MCU to be a hotspot, you can immediately see that hotspot on your mobile devices, right, or Wi-Fi enabled devices. So the hotspot will be listed. So that tells you that the device actually works as a hotspot. And yes, you can connect from a mobile phone to that hotspot, and if you have sockets there, work with those sockets. That's troubleshooting number one. Troubleshooting number two, more complex, is you add a hotspot to the list of hotspots where the device will attempt to connect, and you can add multiple of them. If it fails to connect to the first one, it will try the next one, and so on. So you can do this, and then when it connects, you enter the SSID of the hotspot and the password. Then you can go and check on the hotspot or the router, in general the DHCP, wherever the DHCP server is implemented, to see if the device is listed. The device should become available on the network, and it will be listed as ESP followed by some number device. So that's troubleshooting step number two. Troubleshooting step number three is typically you add a socket. You add some source for that socket. I very often use sign generator because it's easy. You just drop the sign generator, connect it, and you know that it's going to keep sending you some data. So you add a server socket, you connect sign generator to it, and then you can use put TTI or other, you can of course do it in Delphi, but the simplest one is you run put TTI and connect as a raw socket, specifying, if you know the IP address, if your DHCP server has given you the IP address, you can connect by IP address, which is, always works, to that socket, and you can see the data arriving. If the DNS works, which seems like you had some troubles with the DNS last night, for me it has always worked, then you can enter hostname for the module, and then you can resolve it by hostname by entering the hostname followed by dot. For whatever reason, I don't know what protocol they use for domain name registration, but it does require the dot at the end. If you don't enter it, the device will not be discovered. Then you enter the hostname followed by dot and the port number, and you should be able, again, from put TTI or with any raw socket to connect to the device and start receiving the data. So these are the typical troubleshooting steps that I follow. Again, somebody else may have better tips, but that's what I have discovered to work for me.
I also noticed that when I was connecting to the Node MCU for the first time, that the Arduino IDE doesn't know the Node MCU automatically, and so I found this guy here.
I have also made instructable for it.
Oh, you have? Okay.
Yeah, I have done similar instructable myself. Yes. Yeah, if you look at my instructables, I have a tutorial for that as well. It's again a little before that robot, the one you are looking. So it's kind of down the list if you scroll. Just few instructables before that robot. Okay, right there it is in the center of the screen.
Oh, right here.
Yeah.
Okay.
So yeah, this is a long time ago, but there are other tutorials which follow exactly the same thing, which instruct you how to install it.
Yes, you have to point it to the find the 8266.
Correct.
Information.
Yeah. If you remember when I was talking yesterday in the boot camp, I explained that other microcontroller manufacturers, they have added or sometimes communities around those modules have added the integration into the Arduino IDE and the Arduino type API for those controllers. So that immediately pretty much makes those controllers available, and you can install the support for them inside the Arduino IDE. And that is how the ESP8266 works. You add one URL into the Arduino IDE and then instruct it to pull from that effectively URL and install all of the support for the board, and it's quite automatic. I mean, fairly straightforward to do, and I have written this tutorial on how to do it.
Yeah, once I discovered the URL for this guy, that's the key for me. Once I had that, I was like, oh,
yes,
just boop, 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 and it was done. So
yeah, it's simple.
What are some of the differences between the Arduino Nano and the Uno and some of the other different devices out there?
Actually, Arduino Nano and Uno are typically exactly the same thing. They only differ in size. They have the same chips, they have the same capabilities, and even in one of the projects by mistake I simply forgot at the beginning to change to Nano, and everything works fine because all of the pins are the same, everything is the same, just the name and the form factor is different. So the Arduino, traditional Arduino comes with Atmel chip. The Arduino Uno is the most baseline and kind of sort of original module, though it's in its like 5th, 6th or whatever iteration. And then there are smaller factors of this base model, which Nano is one of them. There is Micro, there is Mini, I think, there is Mini Pro. The only difference between Pro and not Pro version typically is that a non-Pro version will have USB connector where you can hook directly into the computer and program it. If it is a Pro version, very often it will be smaller, it will be cheaper, and it will not have this, and you will need USB to serial converter, a separated module, to plug and program the Arduino. So that's the difference between Pro and non-Pro. Typical difference, of course, they don't always follow that standard. And then there is Mega. Mega uses much more powerful Atmel chip, and has many more pins and capabilities and much more memory and stuff. Again, the Uno and Nano, they have very limited, I mean extremely limited amount of memory. Then from there on it kind of becomes crazy. There are versions with multiple processors in it, different types, like Yun I think was one of those. Then there is the Arduino 101, which uses Intel processor and Curie processor, and has the Bluetooth LE functionality and some other sensors built in it. I mean, it's a more expensive, but it's a great board if you want to use Bluetooth. I demonstrated it during Code Rage. And then of course they have exotic things like the Explorer, which is kind of like a remote control with the option to even put on it display. So it has the Arduino plus a bunch of sensors plus the option to install display. There is one Arduino which I don't have myself but sounds quite interesting, which is made in the form of a robot. So it has all the motors and everything else, and even display on top of it, so you can run it as a robot. It's on the Arduino CC website. They're all listed. So those are some of the basic ones, and then from there are literally thousands of clones. Yeah, if you go, I think it's under products, I would expect. Yeah, I forgot. Yeah, and then there are Arduinos that are made specifically for smart clothing, and those are quite interesting. So yeah, it's I mean, it's as I mentioned yesterday, it probably can take me, yeah, Arduino Robot, yeah, this is the one, and next to it is the Explorer. So this is the Arduino Robot. Not very good picture, but it has probably they have better picture down in this page, they should. But it has motors and sensors and everything else, and you can theoretically program it and run it, but I just don't have it myself. And the Explorer is similar, but yeah, these are the motors, and yeah, well, their pictures are not as good as I would have expected them. And Explorer is more like a game controller, so you can probably program some games and stuff like that. Explorer is this guy, yeah.
Yeah, I've seen some with this. It's got the button configuration already built into it.
Yeah, joystick and buttons and option to install display on it and stuff. As I mentioned yesterday, there are literally thousands of boards. I'm not familiar for sure with all of them, and I doubt anybody in the world is. And even if we start talking about the ones I'm familiar with, probably we'll need a week of talk only on the different Arduino and Arduino clones.
Okay. And yesterday you mention you have an SDK available for people that want to expand this themselves, and you can they can work with you if they need help.
Correct. And there is Visuino community, which is quite large community with some helpful people there. I am quite active in the community, so yeah, it's all interaction.
There's a question here, and I had the same question actually. If you're using the Communication Lab socket, I think that's what it was. Communication Lab serial. What was that? Communication Lab.
Comport.
Yeah, if I'm using the comport component, is there a way to read the data directly from this, or do I have to?
Let's see, if I remember correctly, there was event. Yeah, there is one receive event.
On receive event.
Yeah, of course.
So you don't have to tie it to other components, you can just read it directly?
No, absolutely not. It makes it easier, but it's absolutely not required. And yeah, I mean, again, all of this is work in progress. I'm constantly making the components easier to use and more powerful. So if you notice that you're missing some capability that you need, I mean, please let me know, and I'll do my best to add it. That's the way it has always worked, and I lag a little bit behind naturally in terms of what's been posted publicly available and what I have available as internal build. So very often a functionality that you need may already have been implemented. So if you contact me, I can give you a link to one of the internal builds where this functionality is already available.
For your Communication Lab components, I guess, I'm not sure, it doesn't say for sure, what versions of Delphi does it support?
Officially, when the official version is out, I will support XC8, Seattle, and Berlin. The version that I posted on the blog, which is much newer version, is Berlin only, and I do it Berlin only to reduce the size of the installer, which already is quite big, and also testing for each particular environment, the very minimum testing, just the baseline testing, takes about 5 to 6 hours per compiler. So, and that is per C++ builder and per Delphi individually. So testing more than one RAD Studio version is something that I not always have time to do when I post the beta build, effectively.
If somebody gets it with source code, they may be able to get to work on earlier versions, but...
If they need, nothing earlier than maybe XE7 at best will work at all, because the code, I mean, Delphi, if people have not noticed, has evolved a lot in terms of language, not only in terms of components and IDE. The libraries have been heavily modernized to improve performance, to reduce code size, to increase capabilities, to use the latest Delphi language features. And that makes them practically impossible to compile on anything older than probably XE7 is the earliest. And even XE7, I'm not sure if it has all of the features that are needed in the newer versions. XE8 works because, yeah, I make sure that all builds are made on XE8 as well and are verified. But anything older than that, and I mean, why you would use such an old version of Delphi, considering how much great new stuff there is in the newer versions? I mean, it becomes obsolete.
Yeah, really quickly. And the update subscription, actually, we're going to make it so that it you'll see things are just going to keep getting faster and faster. Let's see. There's a question about the tutorial for making custom visuals in Arduino. That's in your wiki, right?
I posted, yeah, that one is on my blog post. It's in article. I posted article in the Pascal magazine. The article is a little bit outdated. Some things have slightly changed. I probably will post a new tutorial quite soon, because, yeah, since, I mean, it was posted more than a year ago, and quite considerable amount of time has changed since then.
Yeah, okay.
But yeah, I have that particular article is available on my blog post. It was posted last year.
Last year.
Yeah,
a month ago.
I should make the blog easier to navigate and work. But yeah, if you search for Arduino, it probably will pop. Yeah, the blog post has the blog post has Arduino search it. I mean, has search itself on the top left corner.
Search built into the blog. That's crazy.
Yeah, right there.
There it is.
Yeah. So if you type Arduino, it should be listed. Oh, right here.
There you go.
Actually,
right here on Arduino Components. Look at that. That's a great search. I knew exactly what I was looking for.
Yeah, it happens from time to time.
Not using Intelligence Lab to read my mind.
You never know.
What is?
I'm not saying.
What is the data storage for the Arduinos for if they're offline, if they're not connecting, sending data straight to the computer? How much data can they store before reconnecting?
I have to. Well, each board is different. The Mega has more memory. I greatly advise you for your particular board to go on the Arduino website or the corresponding manufacturer for the board to check. Let me do a quick search. A quick check into the Arduino site. If you go to the Uno or Nano, they're the same. So
Here's the Nano.
Yeah, let's do the Nano. So if you scroll, it should say the size of the memory. There should be FFM right here, probably in this one. Let's see. No, this is yeah, right here, flash memory. So 32K, 2K used for bootloader. So yeah, it probably some of the memory is used for the code, so it will depend on whatever else is left, I think.
Yeah, so you have to look at how big your what your program is. And
yeah, and then whatever else is available, I think. So yeah, I'll have to check on. But actually, you can connect external micro SD module, and I have done some tutorials on that, and there are also demos included in Arduino. Yeah, this one has more. But you can hook external micro SD card and use that one as a storage, and then you're absolutely not limited. The micro SD card modules that you can get from eBay, I have gotten a couple of them for like around $1 or so. And again, then there is the price of the micro SD card, which seems to be the most expensive item. Yeah, yesterday I was talking about that the advantage of Arduinos over Raspberry Pi is if you get Raspberry Pi, as a minimum you have to get micro SD card, and your Raspberry Pi is not $5 anymore, right? Where with Arduino, if you get like Arduino Nano, it's let's say $4 or $3, depends on where you succeed to find it. And that's it, you have everything you need to actually use it. And you don't have to install operating system and everything else just to start using it, right? You just power it on and it starts working. That's kind of the difference between the Raspberry Pi and the Arduinos.
So a couple people are lamenting that they don't have the latest versions of Delphi, that they're on XE7 or so. They can use the starter. I mean, obviously, it'd be great if they upgraded and got the latest and greatest and all the cool features. Especially tomorrow, as we're going to start getting into some of the RAD server stuff. But you can also use the free version. We have a Delphi Starter Edition. Where's it?
Yeah, well, I mean, I understand that people are complaining, but on another hand, we have a choice. And yeah, I mean, let's see who's going to vote for that. I have a choice. I can try to support those older versions, but not develop Arduino or not develop, let's say, Communication Lab, just because I don't have resources to do both.
Yep.
So, raise of hands, how many people prefer not to have Arduino and Communication Lab, but to have the rest of the libraries, let's say, support some older versions of Delphi? And again, I'm talking probably 2 to 3 more versions of Delphi. I doubt it's going to be a whole lot of people. So, again, supporting old technology means that new technology simply doesn't get developed. It's as simple as that. So that's the price. Nothing is free. Supporting one more version of Delphi takes enormous amount of time and effort, and means that this effort and time will not go into developing other new cool stuff and useful stuff for everybody. So again, if you think that it's worth the price, then yeah, I mean, I can have a second thought, but I personally think that we better have better, more powerful, and more products than supporting something that is, effectively obsolete technology. It just doesn't make sense. It's for the same reason we are not riding on steam locomotives anymore. I mean, they're cool, I like them, I enjoy them, but I think that electrical locomotive is just a better thing than steam locomotive, and I don't see many railroad companies supporting and maintaining and using those steam locomotives. Is the same type of thing.
So Stefan Nealon just came on and said that you should support only the newer versions. No doubt about that. I agree. I think, we got to move forward. It's unfortunate that we can't, everybody can't be on the latest version, but with the free starter edition, support the latest versions. People can upgrade. I went out, and as soon as I saw what you were doing, I went out and bought Communication Lab, so I'm so glad you have that.
Thank you.
Someone does have a question here about the, if they don't have Communication Lab, is there other ways, other components available to talk directly to the Arduino without Communication Lab?
As far as I know, there are a few COM port components. They're not as powerful or as easy to use as what I have created, but they should be available. So if you look around, I'm absolutely sure you can find COM port components that will probably do just fine. I simply haven't used them.
Yeah, I think Async Pro has some COM port components in it. That's the first one I would think of. But Communication Lab was what, $40? Yeah, it was one. Like I said, it was, when I saw your presentation, it was a no-brainer. Buy Communication Lab, buy Visbino, and I'm very happy.
Again, as I mentioned, somebody asked about that. I'm actually odd. All of my libraries are available for free, fully functional for non-commercial purposes. The only downside is that some of the visual components will have a small message saying free version on it, but Communication Lab doesn't even have this problem. And I fully trust that if people use them for commercial purposes, they will purchase. But on the other hand, I don't want to charge people that just want to play or use it at school or something like that money. I'm trying to help people. And again, the reason I'm developing those libraries is although I'm trying to survive as a business, may not be the greatest one in the world, but the reason I created all of that is because I really want to help people to enjoy all of this power and to be able to create great things with Delphi and to be able to create great products and projects. And that's why I have done it, and that's why I try to give as much stuff for free as I can afford, literally. And again, you can see that even some of the products are commercially available and fully functional. I mean, few of our products completely for free. I am trying to help the community and every developer out there as much as I can.
Yeah, and that's one of the things I've always thought makes the Delphi and C++ builder community so amazing is, you know, third-party developers out there like yourself that are making components, and here you're offering for free, or, you know, we can pay them for commercial use, which I think is just amazing. So realistically, you can, you know, I guess you could do all this, everything we've shown so far could be done with the starter edition for free. The free version of Visuino with the 5-minute limit. I don't think any of your stuff in Visuino took more than 5 minutes, and the free version of Communication Lab and the other things. So yeah, but then tomorrow we're going to unlock some more power with RAD server and such. So stay tuned for more power. It's all a matter of how much power do you want and how much stuff you want to do, you know, and how much you want to support the development of things. So anyway, very cool. I think we've got to the end of the questions here. Anything you wanted to add? Stefan Nealon just said he loves your license model. Yes, I do. You know, it's one of those things, and I've had this conversation with other people with it, like talking about some of the new, like when you came out the intelligence lab, it's like, you know, if someone would have said, oh, there's a artificial intelligence library available for Delphi, if I had to guess who it was, I would have guessed, oh, Boyan must have done that, because you're doing all this cool technology. So it's great that you're making it available, so easy for people to get to, and that you're working with us on this boot camp to show people how to just start taking advantage of all these components and all this technology available on the Internet of Things. So thank you, Boyan.
You're welcome, and thank you, everybody. I mean, first of all, you for organizing it, and everybody for attending.
So we do have replay up for day one already, and I'll put my son is my intern, and he does the editing on these, and he'll be working on editing and rendering, getting the day two update, day two replay available for you all right away. So stay tuned for that. It'll be available at the embt.co/ well, if you just go to the main page. There's too many blog posts. Okay, you'll see it on the latest blog post. If you just go to blogs, Jim McKeith, you will see boot camp. It says boot camp day 1, and boot camp day 2 will be on here later today. Here's, if you're interested in the latest blog post with Nick and I, we're talking about some of the cool apps out there. There's some really cool apps. And also I found out Niagara Falls has this huge array of RGB LEDs that they shoot into the falls to light it up. And the software behind that is powered by Delphi, of course. So we're looking to have a case study we've done with those guys that did that. They just launched that a couple years ago, I believe. So very cool to see Delphi out there powering all these devices everywhere. They're probably using some of Boyan's software, I'm sure, in there as well, because I think everybody is at this point. Anyway, thank you so much, everybody. And actually, we're just talking to Stephen. We're going to send out a survey just to get some feedback on this the boot camp and see what everybody thought. And if you give us some quotes about how great it was, that would be great as well, just so we can help spread the word and do more stuff like this in the future that to show you guys some of the power of some of the great technologies that are out there. So we'll see you all tomorrow, where we have Craig's going to be online with us tomorrow. He's online with us now, but he's been a little quiet, I guess. And he's going to be helping out with showing us how to connect all this stuff together and build our big network. I guess this is where we're going to unlock Skynet, right? Where it's going to be all connected. And okay. Any other libraries? Oh, there you are, Craig.
I'm under the same NDA that Boyan is with regards to Skynet. Sorry.
I see how it is. Okay. There's question here says, communication is allowed in async pro used for communication, any API, or the library to access sensors or other components. It all comes down to, when you're talking to Arduino, you have to talk to it either over Bluetooth, serial, or Wi-Fi in the case of Node MCU, right? That's the API, is you have to be able to talk over those ports.
Yeah, I can probably try to answer. In essence, first of all, Visuino typically has components that know how to talk to the specific sensor. So we demonstrated some of those as example. I did yesterday, yes, yesterday I did example the accelerometer and gyroscope sensor. It's an I2C sensor. It uses I2C registers. It has its own effectively API and ports where the data is read following certain rules. There is component in Visuino that you drop, and this component knows how to decode the data from the component over the I2C communication and convert it into acceleration, gyroscopic movement, and temperature data. And once the data is decoded into those, then you can simply use packet communication, exactly as we did in some of the demos, and send it to Delphi, unpack it there, and the data is immediately available, already decoded and already in the form of useful acceleration, rotation, and temperature data. So that is how it is handled typically.
Okay, great. Someone's asking if there's biometrics applications of IoT. There's a lot of those out there. I've seen all the different kind of biometric scanners are available that you can connect to as well. Actually, just yesterday, one of the MVPs, and I can't remember his name now. I apologize. I should share that. I think I still have the link. He sent me a video. He'd built a device that could read bills. So if it was like on the like a vending machine, right? Where you stick your money in there, it could read the bill and to see what it is and send it to a Delphi application so the Delphi application could see what bill was inserted and then decide how to process with that. He built all that with Delphi as well. So there are so many different devices out there, and all of it you can. We're just barely scratching the surface of what you can do with Delphi here today, but hopefully enough to get your creative juices flowing and for you to see some of the potential and some of the basic functionality you need to get started with this. So, all right. Thank you so much, everybody, and we'll see you all tomorrow. Our hour went a little over. I think it's 2 hours again today. Wow. So much stuff to talk about. Thank you so much, Boyan, for all you do, and for Craig. And Stephen had to step out because it's family time. He's over in England already, so it's very late in the evening for him. And we will talk to you all tomorrow. Thank you. Bye-bye.